Assalamualaikum. My name is Muhammad Alif Aiman bin Abdullah. My team member is Muhammad Abdul Karim Abdul Rahman Ahmed. Today I would like to present about recyclable material classification by using convolutional neural network. My lecturer name is Dr. Herdawati binti Abdul Qadir. I was from group 11. So this is our assignment 2. For the introduction, the convolutional neural network is one way to obtain the dataset and also known as ConNet. CNN commonly used to analyze visual imagery and are frequently working behind the scene in image classification. The CNN can take in an input image and assign potent learnable weight and bias to various objects in the image and able to differentiate. The pre-trained models that have used in this project are CNN, VGG16 and DenseNet. This is introduction to convolutional neural network. CNN is a deep learning algorithm which can take in an input image, assign important learnable weights and bias to various aspect objects in the image and be able to differentiate one from the other. CNN have the ability to learn this filter or characteristic. CNN is reducing the number of parameters in artificial neural network (ANN). Introduction to visual geometry group VGG16. VGG16 is 16-layer deep neural network VGGNet. VGG16 is extensive network and has total of around 138 million parameters. The ReLU is a linear rectifier function which is an activation function for the neural network. Introduction to densely connected convolutional network DenseNet 1-to-1. DenseNet is a sort of convolutional neural network that makes use of dense connection between layers through dense block which connect all layers, specifically to improve the decline accuracy caused by the vanishing gradient in height-level neural network. So that's all from my part. Assalamualaikum. So this is the coding for the task 1 group 11. So first one we mount from Google collect import drive mount content drive. After that we input OS chdir content drive my drive recycle os dot get cwd. After that path content drive my drive recycle train del, and after that we get the output. Can train is 156, factoring length is 310, can val length 77, pet val length 133, test can pet length 3. After that we code. This is our code and run. After that we make the new coding. So this is CNN 6433 ReLU 150 153. Match pooling is 2. Convolutional 2D 6433. Match pooling 22. Convolutional 2D 12833. Match pooling 2D 22. Convolutional 12833. Layers 0.5. Layer dense 152 and TF cross layer dot dense is 1. So we run that coding. We get convolutional 2D param is 1792. After that convolutional 2D5, we get 36,928, as you can see. After that, we get 73,856. After that, we get 147584. After that, dense 2, 14746,112. Dense 3, we got 513. So the total parameter is 15,006,785. Trainable parameter also same with total parameter. After that, we run again using this coding. And we found at output 466 image belonging to classes, found 210 image belonging to 2 classes. Database shape is 8, 150, 153, label base shape 8. So we coding again for the next code, and we get this loss accurate val accurate for the 1 by 1 of the epoch. So we use we run 10 epoch. So this is first epoch, second epoch, third, 4, 5, 6, and until 10 epoch. So that is all the result that we get for the 10 epoch. After that, we code for the graph. So we got this graph, training and validation accuracy. So 02468 for the epoch, and the second graph is also same, training and validation loss. For the first is accuracy, for the second is loss. So that's all from my part. Task 1 using CNN.
Hello, Assalamualaikum. I'm Muhammad Abdul Karim Abdul Rahman with matric number of BE 190009. So, in this presentation, I'm going to present the methodology part, which is the from our assignment 2, group 11. The course subject is vision system under Dr. Redawati binti Abdul Qadir. So let's proceed for the methodology. So as you can see, in our assignment we have two tasks, which is task 1 and task 2. So this flow chart is for task 1. First you need to start then loading data from the Google Drive, and then training symbols, convolutional layer, then proceed with max pooling, and then we proceed with convolutional layer, and then max pooling, convolutional layer, max pooling, then dense. Of course, we are using 3 times for the maxing and convolutional time, and then dense. We proceed with dense, then we can proceed with CNN based feature learning, and then training symbol features, and lastly the M classification. Then we can obtain the output of the classification results. And so here is the flowchart for task 2, VGG. Then start pre-train type VGG16. Then we construct the CNN model, and then load data from Google Drive, then import the relevant file, and then construct the pre-trained model, and then feed the pre-trained model to the structure architecture, and then proceed with pre-process the input data, then setting the setup pre-epoch, and then the epoch, and then the validation steps So then to start the training process, so here we then can be able to plot the outcome of the CNN model using VGG16. So this is the end of the task 2 using VGG, and then here is the flowchart for task 2 using dense net. So here also we need to start first, then pre-train the type is dense net, as we are using here dense net. Almost the process are same, except the train type. The train type here was VGG16, and then here we are using dense net. So the construct CNN model and then loading data from Google Drive using 2D convolution layer, max pooling, flatten and dense, and then pre-process the input data and then setting the steps here, epoch, and then epoch and validation steps, and start the training process in order to plot the outcome of the CNN model using dense net. So here this is the demonstration at the Colab notebook. So for my task is task 2. I'm using the train type is VGG16. So let's go and see what happened with the code. So here first we need to connect to the Google Drive, which is as we can see here already connected to the, you can just click here and then it will connect. I already connect to my Google Drive. Then we need, in order to run our code in Colab Google, then we need to upload our files first, our folders that we need to use it in our assignment, upload it in our Google Drive, then connect the Google Drive with Colab, then you can proceed with your code. So as you can see here, I already named my file as my folders as Colab notebooks, and then recycle, and then test. We need to test the 3 pictures, then train, and then bulk. So all these files are inside the recycle, and then the recycle file also inside the Colab notebooks, notebooks file. So here now you can just write your files name to call the files from the drive. So let's run and see what happened for the first page here for to connect the Google Drive. So the drive already mounted at the content drive, so it means that already we are connected to the drive. So here, then for the fit dataset directory, so we just run new connect drive, my drive, Colab netbooks recycle. So it's calling from the drive. So here is we need to create train and validation. So in order to create the train and validation data directory, so we just use this code to call to get the can train links. These values are the can train links is 156 and pit train links 310, can val links is 77, and then feed val links is 133, and then the test count bit is 3. So as you can see here, our pictures are only 3, so the links are 3. So then next we need to construct the pre-trained model with VGG16. So in order to get into the VGG16, we need to improve the dense flow as the dense flow. Then we can write here our code, and then we can get the VGG16 outputs. So here, as you can see, the values are for the model is VGG16, and then here are the layer type, and then the output shape, and then the parameters. So as you can see here, these values for the these are the layer type here, input layer, and then convolutional 2D convolutional, max pooling, 2D max pooling, convolutional, 2D convolutional, 2D max pooling. Here are the output of the shape, as you can see the outputs, and then the parameters. Those values are for the parameters. Let's see the total parameters. So here are the total parameters for this section. 14,714.688. The trainable parameters are 0, and then the trainable parameters also are 14, the same value, 14,000. And then the pre-processing to the input data. So let's run and see. Here almost the total parameters are 18,000, and then the trainable parameters are 4,195. The non-trainable parameters are 14,000, same as 14,714. So here, as you can see, for the start for the training process, okay, here we found in this section found the output 466 images belonging to 2 classes, and then found 210 images belonging to the 2 classes too, and then the data batch shape 20, 150, 153, and the label batch shape is 20. So here then we need to start training for the process. So as we can see here, we already give values for steps here. Epoch 5, and the epoch is equal to 15. Then validation steps are 10. So let's run and see. Okay, here are the output of the epoch. All these values for the validation and epoch. So let's so now last section, which is to plot the our graphs. our training and validation losses. So let's run and see. So now, as we can see here, is the graph that we have got. So this is the training validation accuracy. The blue point is for the training accuracy, and the blue line is for the validation accuracy. As we can see, the validation accuracy. Okay. This is the training and validation loss. So that's all for my part. Thank you very much.
For the result and analysis, so this is the graph for the task 1. Training accuracy is equal to 95.75%, and the validation accuracy is equal to 87.38%. So this is the graph. For the training and validation loss, training loss is equal to 14.47%. The validation loss is equal to 74.57%. This is for the task 1 using CNN. For the task 2 using VGG, training accuracy is equal to 96.75%. For the validation accuracy is equal to 90.9%. For the training and validation loss, training loss is equal to 9.21%. Validation loss is equal to 30.17%. Consequently, when compared to the two models CNN and VGG, the DenseNet model obtained the best accuracy. These three models all utilize the same image from a Google Drive folder. To summarize, the DenseNet model in task 2 is the best model for extracting features from pictures with the highest accuracy and least loss. As you can see, this is the table for the different for the three model that we has used. For the conclusion, we had learned how use Colab notebook to accomplish assignment 2, which is recyclable material classification by using convolutional neural network CNN. Second, the system can accurately detect pictures when presented with image of PET bottles and aluminium can provided to us. CNN has an excellent capacity sequence data analysis such as natural language processing. CNN consists of two basic operations, which is convolution and pooling. VGG 16 is 16-layer architecture with a pair of convolutional layers, pooling layers, and at the end of fully connected layers. DenseNet was created primarily to improve the vanishing gradient induced loss in accuracy in high-level neural network. So that's all from our group. Thank you.